Hello everyone, it's Fahad here again with the second lecture of Brave Simulator for Signaling Control System. So in my previous lecture, I have just finished the development of paths, and now we will continue from that point. So after introduction of paths, you will have to assign a track circuit to each path, whatever you will develop in your graphical panel or whatever is the network that you are going to design. First you will have to develop the complete path, and then you will have to introduce the track circuit. So you might know aware about the track circuit from my previous lecture. Track circuit is used to identify the train location or position on the network in traditional signaling control system. So once you have developed a path, then you will have to assign a track circuit to that path so that you can understand the position of your train while it is running on that path. So for that one, you will just select the starting point of your path, and then you will have to so you will just select the starting point and the end point, and your path will be converted in a track circuit. Now whenever the train will be on your path 1, automatically it will not allow another train to come into this section. This section will serve as a block. So as soon as the train 1 will enter this path, it will show a red signal, because it means that this section of path is already occupied with a train and another train cannot enter into this section. So this is the purpose of track circuit in this simulator. So you will have to develop your whole network one by one into several paths as much as you like according to your design, and then you will assign a track circuit to it for the identification of your train location. So once the track circuit is assigned, then the next step is to assign a route, because on a certain network there might be number of lines. For example, from one line can from station A to B, another route can be from station A to station D, which might have several branches, and so on. There might be several junctions. So every time you will have to assign a route to a train. So there might be a number of routes on a several line. So you will again simply select the line, and it can be converted to your it can be converted into a route. Okay, so after assigning the route, you will have to add a service. Okay, you will click the service tab, and then you can see you can add the vehicle by choosing the vehicle tab. Just right click, add vehicle will be added. For the default purposes, it is only one car vehicle. You can change into number of cars as per your requirement. So I am adding it to 6 cars. Okay, so as soon as you will add the 6, it will show in the model as well. You can see it is 6 number car vehicle, and there are characteristics about the vehicle itself. You can see the speed and kinetic force, the force, traction force for that vehicle. So you can change these variables according to your design requirements. Okay, so let's say I want to change it to 10. I can change it by typing in this space. So accordingly the things will be adjusted in your model. Okay, so you can add number of trains, number of vehicles, number of routes. So whenever now this is the vehicle section. So if there is a junction, it is compulsory for the simulator to add a point at junction point. Otherwise your system will not, the simulator will not work in the way it is supposed to design. So for that purpose you will just select the configured junction point. It is shown by this way. So there is a position for the junction. Okay, so you can if for the time being, for the example of this video, I haven't introduced a junction, but you can add a junction just by clicking the point where the junction is located, and after that you will be able to add a signal to this junction point, because without any junction point you cannot assign a signal to that point. Okay, the position of signal depends on you, how far you want to introduce the signal from the junction point, but you cannot assign a signal without a junction point. Okay, so that is how this basic traditional signaling system can be developed by using this simulator. Okay, now but for the purpose of this video, I'm not going to do all the steps that are required to develop a complete setup for running the simulator, because it is gonna take a lot of time. Okay, so University of Birmingham, they have already developed a design network, and there is already a model. Okay, I am just going to show you the model which has been developed already for a section of network, and it is already in my database. So I am just clicking the model. It is asking me I am going to save this one. No, I am not going to save this one. I think it's giving some error. I am trying to close this one, but it is not accepting this one. So let me just close this simulator. So I have opened this build up model. I will just zoom out. I want to show you. Now if you will go to the information panel of this simulator, you can see there are a number of stations on this network. There is a timetable for each one of these train network. There are routes which have been developed. There are junctions. No, they are not junctions, has not been defined. So there is infrastructure about the points, about the parts, about the tracking circuit. Everything is already built in this one. Okay, so what I want to show you, that how this simulator is working if you have a complete network of your signaling system. There are number of stations on this network, and there are number of trains which has been designed to run on this one. So we will see how this gonna work if you have developed the whole network of your signaling system. Now it is showing there is a train with S1 identification number.